to the group exhibit Hydrogen Fuel Cells and Batteries at the Hanover Fair 2017. We are here at the Technical Forum and my name is Muriel Buakas. I would like to also give a warm welcome to our guests watching the presentations today through our online through our live streaming. Please join us for the upcoming presentations, have some coffee, have some refreshments. And I'm very much looking forward to the next presentation regarding the topic, the case for containerized hydrogen solutions. Please welcome with me on stage President of Engineering, Procurement and Constructions, short EPC, John Cornish.
Thank you. Thank you. My topic is going to be to talk about the need to containerize hydrogen systems. To maybe justify that and put it in perspective a little bit, in the US there are about 150,000 gas stations. Gas stations are just one market, of course, for hydrogen, but if over the next 20 years we're going to put a hydrogen dispenser at 20% of those stations, that will require the manufacturing of systems in the order of 5 or 6 a day. Starting whenever we decide to start the 20-year clock to put all those hydrogen stations out there. So that's a lot of equipment, a lot of materials, and currently there's no manufacturing capacity in the world to start fabricating and assembling those. So first I'm going to show you a little bit about how stations have been built so far over the past 10 or 15 years, and then talk more specifically about a factory we're building that will containerize all kinds of hydrogen systems, not just fueling stations, but electrolyzers, reformers, compressors, Haber-Bosch systems for ammonia, anything really that needs hydrogen. So the standard approach to building hydrogen fueling stations, and I'm going to use that as an example of systems that could be containerized, is to start by doing a ground penetrating radar survey of the site to make sure you identify any underground obstructions and things that may cause a problem when you start to dig below the ground. And basically nothing good ever happens underground. As soon as you start turning over the dirt, you find surprises and problems that add to the construction cost and schedule. But after the survey is done, you have to have soil borings done to test the soils and design the foundations for all the equipment. The more equipment there is, the more foundations. So it's in everyone's interest to minimize the footprint of the equipment, minimize the number of containers or the number of modules that go on a site. Following that comes the actual installation of the underground services. Typically, it's mostly electrical conduits, some hydrogen and chilling conduits, some water supply, and this is a picture that shows some of the type of underground work and site preparation that has to be done. Often this is done by, or it can be done by, a local engineer and local construction company. There's no real relationship from this work and the hydrogen system per se, so no particular experience is needed in high-pressure hydrogen systems or the stainless steel piping or the area classifications. So this could be done independently, really, of the hydrogen system. And then after the foundations are prepared and the walls, typically a big crane is brought in for a day or two. All the equipment can be set on site, and then begins the process of interconnecting the components before power is actually applied and the system is commissioned. So that should give you some idea of the typical approach to date. And what we're proposing and what the industry, I think, needs is a more modular design. And many of the big companies, Air Liquide, Air Products, Linde, have gone to modularizing their equipment because it's in their interest to standardize the designs, to reduce cost, and to make operations and maintenance more of a standard procedure, that the same people can go to different locations and service the equipment similarly. So in the approach that we're proposing, the systems will be reduced in size and scope to the minimum possible footprint and the minimum number of containers. And a simple foundation can be prepared, again, by a local company without any real hydrogen expertise, just doing the stub-ups for the interconnections. the factory that we're building will start standardizing the manufacturing processes for things like wiring harnesses. They can be prepared as a subassembly that can be installed inside the container or the module by unskilled technicians. Similarly, from 3D modeling of all of the systems, the tubing between modules, such as an electrolyzer and a compressor and a storage tank, can be prefabricated. They can be alkaline washed and cleaned. And again, it doesn't take skilled labor then to take the biggest piece of tubing that's exactly properly fabricated, take it through the doors and connect it to the components. So this reduces the overall cost of assembly. Structural modifications also need to be made to the containers. Some companies, Air Liquide, for example, has custom-built containers for their systems. Others use prefabricated ISO containers that are very inexpensive. But there's always modifications that are necessary for supports and for aligning the equipment to provide the functionality that's needed in the ultimate system. So this is a rendering of what our particular factory looks like. It's coincidentally very similar to the one H2 Logic is building for fueling stations as a module, and they're making great strides in reducing the footprint of those and making them easy to install. In fact, we're working with them on a very minimalist foundation design approach that will reduce the need to pour a lot of the concrete pads by putting them on piles instead of on concrete foundations. We're doing a number of optimization studies as the factory design is completed in three main areas. One is called advanced manufacturing, which is a big buzzword in the industry right now. In order to minimize the process footprint itself, we're looking at continuous parts reduction on behalf of our clients. We don't actually sell a product per se, we build them for clients. So we would assemble containerized systems for, say, a Haber-Bosch system that would need a number of containers to go on site. And by modeling the piping and the wiring, we would minimize the parts counts and reduce the overall cost and time of assembly. Robotic applications are being studied for this type of thing, and you might not think there's a lot of robot applications for this, but actually the structural modifications are a good candidate to be done robotically. Cold plasma laser cutting and grinding, painting can all be done without manual labor. And so we're hoping to find the right kind of machines to actually pick up an entire ISO container and move it around in front of the plasma container, roll it over to cut the vents and the holes. So the whole thing will be an automated process to make the structural modifications to a prefabricated container. Another type of studies that we're doing is to obtain ISO 9001 certification for the factory. There is no facility in the world that's making hydrogen systems in containers now that is ISO 9001 certified. That's the certification for continuous quality improvement. And it's a mandatory service for many large organizations like Air Liquide that if they go to mass manufacturing of these facilities, it'll have to be done in a facility that has ISO 9001 certification. We will also have PLC fabrication on site, and we'll have what's called lean inventory management systems that is part of the total quality management to reduce the time from receipt of parts until installation and delivery. The final feature of this, which doesn't show particularly well in this, is a test facility. As electrolyzers, PEM electrolyzers get bigger and reformers become smaller, there are a distinct need to actually test the equipment in an assembled condition before it goes to the final location. So we have a 7 megawatt power supply that can run fairly large PEM electrolyzers and up to 500 standard cubic feet per minute of natural gas to run reformers. So we can take the finalized container system, put it out in a safe location, and actually run it under test for an extended period of time, so that when it actually gets to its final location, it's simply a matter of making the interconnections between the existing utilities, turning it on and running it. And a system like that could theoretically be started up in a matter of days, rather than the current condition where debugging and commissioning often takes months. So that's about it. In conclusion, I just want to repeat that hydrogen system containerization is going to be necessary if the hydrogen economy is going to grow and expand at the rate that everybody hopes it will. And there are no current facilities in the world that are designed specifically to containerize hydrogen systems. So ours will be among the first, certainly not the only one, but it'll become available for production about this time next year. We're welcoming your inquiries. We'll provide estimates, and we are doing some assembly in smaller facilities that are rented right now until this all happens. So if you want to see me and talk more about this, we're at a little booth right over here, C38. I welcome your questions and look forward to talking to you more about containerized facilities. Thank you.
Thank you very much, John. Are there any questions from the audience? Yeah? Yes? Here in front.
Good. Yes, sir.
Is a hydrogen container which you are going to manufacture comparable to an isotank?
Comparable to what?
To an isotank.
Similar. I mean, ISO containers, shipping containers, you know what they are, that are on trains. You can stack them double. Shipping containers, yeah. They're very inexpensive. That's why they're used. They're $3,000 or $4,000 for a 40-foot container. So that's a good starting point. But many technology vendors have their own custom designs as well. And cost reduction is obviously a huge thing. The entire delivered capital cost of hydrogen equipment is far too expensive, and it's got to come down. So this is a way to do a bit of it. It won't affect the cost of an electrolyzer or a compressor, but we could probably assemble them for 30 to 40% less cost than is currently being done.
Further questions? I was wondering, you started the company in 2003, right?
Yeah.
Okay.
Yeah,
fine.
we've been doing this for 16 years and have built a lot of the fueling stations in California, a lot of forklift stations across the United States, and participated in one FCHJU project over here in Italy.
Okay. And now this is the newest approach.
Yeah.
Or the newest product.
Yeah, I'm tired of digging in the dirt and finding surprises underground. So I want to just put a container on top of a couple piles and walk away.
Easier. So what do you expect? You will start production or commercialization next year?
We actually are producing containers right now for export to Africa for power modules. But we'll start large production go back. This. Whoop. These are each 40-foot containers that's represented, and many of the containers won't be 40 feet long. There are smaller ones as well. But there's 38 workstations here. Each one will have a large CRT screen, so it'll be paperless transfer of the drawings from the design shop over here, where the engineers and draftsmen are, to the work floor. We also have what we call proprietary exclusion. We can put big sheets and walls between certain areas. So if these were being made for Air Liquide, for example, and these for Linde, people couldn't see across the walls and see each other's technology. So we can keep data safe and secure from competing technologies. But it's more likely that these will be for a broad range of products that won't necessarily be competing. So right now, we're producing these in rented space, and we can only produce two at a time, only work on two at a time. And this will be open in about August, we hope, of next year, of 2018.
Thank you very much for this presentation, John.
Thank you.
The next presentation will continue in about 5 minutes regarding the topic Reform Methanol Fuel Cells, Enabling the Methanol Vision with Zare Energy. I'm very much looking forward. Please stay with us, have a coffee, have some drinks, and see you in a few minutes. Thank you very much.